Hello guys, this is CodeNCode and this is 6th lecture of the segment tree series, and in this lecture we are going to see and study lazy propagation, which is range updates on segment tree. So the first question is, what is lazy propagation? But before that, let's answer this question, or let's see what is the problem with range update when you do a point update for a whole range. So suppose you are given a whole range. In worst case, the range can be from 1 to n, so you have to update all of the elements in 1 to n. And say you are having a range sum segment tree, and then there is a query to add element 10 in all of the numbers from 1 to n. Now what you can do, if you use point update for n times, of course to update one element it takes log n time. So there are n elements in worst case, so in worst case range update using point update can be as costly as n log n, which is too much. But if we use lazy propagation technique for range update, the same range can be updated in at most log n time. So the main idea of lazy propagation is update only when needed. So I'll show you how this makes sure to do this. Now the thing with lazy propagation is that you can understand it with an analogy. Suppose we are talking about a person, say me, which is lazy. So what I do is, whenever there is some work, what I do, in my mind I think, okay, I'll be doing this only if needed. What's the point of doing something when you don't even need it right now, right? So I can push that work to do later. So and there are more than one work, and if I keep pushing things to do later, I may forget some of the things. So what I do, I create I have a diary with me. So whenever something comes and that is not necessary at current time, so what I do, I write down that work in my diary, that I will be doing this work later. So I'll be calling this pending work. So I have a diary in which I write down all of the pending work. So whenever needed, I'll see if I have that update, and when the time comes, I'll see whether in that diary I have certain updates that need to be done at this moment. So that diary that you have is actually lazy tree. I'll be showing you the lazy tree in a moment, but before that, let's see what first let me show you something, what happens when you have a range sum query, and then I'll be showing you how range query is exactly the same as range update using lazy propagation. There is a very little change in uh, range query, be it range sum or range minimum or anything, and the lazy propagation. There is like 90% of similarity between these two. So let's see what happens when you have a range sum query from 4 to 8. So these are the nodes. I have 8 nodes, and this is a segment tree which represents the sum of certain ranges. Now the node 1 is having value 1, node 2 is having value 1, node 1 is having value 3, node 2 is having value 1, and node 5 is having value 8, and so on. Now we have a range sum query 4 to 8. We see if you add all of the nodes from 4 to 8, you see the sum is 11. So what happens when we make a range sum query is this: you reach first node and you see, okay, the range is 1 to 8, while my range query is 5 to 8. So this range doesn't come completely inside your query range. That is why, and this, there is an overlap between this range and your query range, right? So that is why you would make two recursive calls, left and right. That is what we have done here. As soon as you reach here, you see 5 and 8 lies completely inside your query range 4 and 8. So all of the elements in this range will form a part of your solution. So that is why you can directly return the sum here. So you directly return sum from here, and you do not go down because you don't need to. Now for the left part, you see, okay, 1 and 4 doesn't lie completely inside my query range, which is 4 and 8. So what you would do, and of course there is overlap between 1 and 4 and 4 and 8. So what you would do, you would make two recursive calls, first left and right. I'm not showing you the left one because you reach left and you see, okay, 1 to 2 is completely outside my query range 4 to 8, so you would directly return 0 from here. Now you would reach here, again the same thing happens, so you would make two recursive calls. The left one would return 0 because that is completely outside your query range, but the right one is completely inside your query range, so you would return 0 from here because this node contains value 0. So you would return 0 from here, 0 from here, 0 from here, 0 from here, all the way up to the root node. You would return 0. From here you would return 11. So the sum of these two is 11, so of course you got 11. This is what happens when you make a sum query, range sum query. Now let me show you what is lazy propagation. Now see, as I in the analogy I told you that we have a diary in which we keep all of our pending updates. So this is the diary, the lazy tree. Lazy tree is nothing but exactly the segment tree. So the size of a lazy tree would be an array like segment tree. Now for each node in the segment tree, we have corresponding node in the lazy tree in your diary. So you will be keeping pending node pending updates here. So if someone's if the value of say this node is 2, that means in the range 5 to 8, because this node represents this in the segment tree, this node represents the sum from value from index 5 to 8, right? If in your diary for this node you have, instead of 0 you have say 2, that means in the range 5 to 8 you have a pending update. That means you have to add 2 in the range 5 to 8. So all of these elements needed to be added by 2. So let me show you what happens when there is a query add to 4 8. That means add value 2 in all of the elements from range 4 to 8. So 4 to 8, all of these values will be incremented by 2. Let me show you what happens when we apply lazy propagation. You would go to here, you see, remember 4 to 8 is exactly the same query as we have seen here, the range sum, because I want to show you what is the similarity when you do an update using lazy propagation, and this is how you would understand how lazy propagation works. So what you would do, you would go to update range 4 to 8. You do everything the same way you do for range query. Okay, so you see, okay, 4 to 8, 1 to 8, this range doesn't lie completely inside my query range, and also we are having what we say, these two overlap, these two range 1 to 8 and 4 to 8 overlap, and 1 to 8 doesn't lie completely inside my query range, so I cannot return 20, but I have to go left, but I have to reduce the range and make two recursive calls. So you would make two recursive calls left and right. Okay, so now you reach 11, and what you do, you reach 11 and you see, okay, 5 and 8 lies completely inside my query range 4 and 8. So what you would do, you know that, okay, inside this range every node will be incremented by 2, right? Because this lies completely inside the query range, so all of the element from index 5 to 8 will be incremented, all of the values in this range will be incremented by 2, and this represents sum of 4 elements, right, which are from 5 to 8. Now this node will be incremented by 8, so this would become 19. Why? See, it stores the sum of 4 nodes or 4 values from the array. All of those are going to be incremented by 2, so the overall increment would be of length, of value 8, 4 times 2. So that is why we have added 8 here. Now this node has been updated, so what do next? After you update this node, since this was completely inside your query range, what you would do, you would go left and right? No. in range sum, what we do, we simply return from here and return this sum, right? In update, what you do, you have updated this, and for these two nodes, the children and the rest of the nodes, we would not update them because we do not need to. So what you would do, you would, in your diary, you would mark, okay, I need to update this range and this range, basically your child of this node. So in your lazy tree, the left and the right child of this node, you would write down the pending updates. So you would add 2 and 2 here, indicating that this range needs to be updated by 2 and this range needs to be updated by 2, right? So what we have done, we came down here only till here, and now we have updated this node, and for the rest of the node I do not need to go further down. So what I'll do, I'll simply add values 2 and 2 in the left and the right child of this node and simply return from here. So you see, in the range query also we return from here, and in lazy propagation also we are returning from here, keeping in mind keeping the record that okay, these two ranges have to be updated by 2. Now you would go left, you reach this node, and you see okay, 1 and 4 doesn't lie completely inside my query range and we are having certain overlap. So I'd make again recursive call left and right. Here this is completely outside your query range, so you directly return from there without doing anything, because this range need not to be updated because this is completely outside my range. So you'd go right, again same thing. So you'd make 2 recursive calls to update left and right. Left would have nothing because outside the range seen, and the right one lies completely. Now you reach this node which stores the result of 4,4, which means this range comes directly and completely inside 4 to 8. So what you would do, you would update this element, and this element will become 2. But since this element does not have any children, because segment start and segment end is equals are same, so this does not have any child, so we do not have to update in lazy tree the children of this node. So we would directly return from here because this node doesn't have any child, so of course we don't have to update anything in the segment tree, or we do not have to, or we basically don't have any pending update. If we do not have any pending update, why would we update our diary? So we would return from here. Of course the left and the right, one of the node were changed, so we would update it. So this would become 7, the simple range update thing that we do. When you make 2 recursive calls to update either your left or right child, what you do, when you come back, you update the current node as well. So you made 2 recursive call left and right, one of them must have changed, so this node also updates itself. So this would become 11, 7 and 4, 11. And of course this node made 2 recursive calls here and here, both of them node have been updated, both of these node have been updated, so this would update as well. So this would become 30. Now you might think, okay, what would happen if I have to find the sum of node 5 and 6, that is if I have a query sum 5 or 6, because these two nodes should have been the value stored at these two positions should have been 10 and 5, because this whole range was updated by 2. So this should be 10, this should be 5, this should be 2, and this should be 2. But these are not updated because we have postponed the update for next time. What happens when you make a query 5, 6? So let's see what happens. So first we will come here and we'll see that okay, this range doesn't lie completely inside our query range, so we would make 2 recursive calls left and right. Now once you reach here, what you would do, from there you directly return, because 1 to 4 is completely outside your query range 5 to 6, so you would directly return 0 from there. The simple thing that you do in range sum query, right? Now for this node, what you do, you would again see 5 and 8 does not lie completely inside my query range, but we are having certain overlap, so you would make recursive call. I'll show you first this recursive call and then I'll show you this recursive call. So you made this recursive call. So you are at this point. As soon as you reach this point, whenever you reach any point during your update or your range query, you check in your diary whether this node whether for this node there is a pending update or not. So whenever we reach this, we check do we have any pending update or not. If we have any pending update, we take care of that first. I didn't explain you this before because there were no pending updates at all, but this node, when you reach here, you see there is a pending update, right? Whenever you reach any node, first thing you check whether there is pending update or not. This is the first thing you check, then you would write any other code. So you see, okay, there is a pending update. So what you would do, you would update this node, and again you would do the same thing and add in the diary, update the child of this node. So first let's update this node. Now there is a pending update for this node and it says 2. That means this whole range will be updated by 2. How many nodes are there in this range? Of course there are two nodes in this range, so this value would be updated by 2 times 2 because both of them will be incremented by 2. So this will be updated by 4, so it would become 15. Now this has become 15, so we have completed this pending update. So what we would do, we would make this 0, and also since this node have been updated but the left and the right node still needed to update it, so of course what you would do, since you have updated this node, you would in the diary you would increment these two nodes by 2 and set this value to 0, which indicates, okay, I have taken care of this update. So there is no pending update for this node, but for these two nodes there are pending updates. So in lazy propagation, whenever you update certain node after completing your pending update, of course you update its left and right child. So in the diary, what you would do, you would add that value which was here initially, because you have updated this node, you would add that value to left and right child, indicating these two nodes also have to be updated by this value. After this, you see, remember this was the first thing, whenever you reach your node, you see whether there is a pending update or not, and then you take care of that update. So we have taken care of that update. Now we continue with the same thing that we do for range query. Now we'll see where we see that, okay, 5 6 lies completely inside my query range, so I'll return 15 from here. So see, from this range the sum should have been 15, and we see that sum is actually 15, so you would return 15 from here. After that, you would make a recursive call to this node. As soon as you reach this node, what you would do, you would see whether there are pending updates or not, and yes, there is a pending update. So you would update this, add 4 to it, because of course there are two nodes in its range and both of them will be incremented by 2, so this node will be incremented by 4, the number of nodes multiplied by the value. After you have updated this, you would pass this pending update to your child. So you will set this to 0, but the left and the right child will be incremented by 2, indicating that these two nodes have to be updated in future if you come to these 2 or these 4 nodes during certain range query process. So you see, from here we see, after we have taken care of update, we will see whether we'll continue with the range query scene. So we see, okay, 5 7 is completely outside my query range, so you would directly return 0 from here. So this node returns 15, this node returns 0, so 15, sum of these two is 15, so this node would return 15 and this node would return 0, so finally you would get 15 as your result. Of course the sum of these two nodes is 15, because this would be incremented by 2, this would be incremented by 2 again, and the sum is 15, which is correct. And we see that these nodes have pending updates. So this is your lazy diary that you keep with yourself for any pending update, and then you would update if and only if you have to update that node. You would not go down to the bottom by making update, but we would go only till that point where this range completely lies inside our query range. In that case, we would update that node and pass, and in the lazy tree we'll mark the children of that node with pending update. So this is the main idea of lazy propagation. In the everything seems over the head when you only think about the theoretical part. So in the next video I'll be taking a range some problem if there is if that is on any online platform like code forces or something. If there is some problem I'll be taking that, otherwise we'll go for the range query by ourselves. So we'll write down the lazy propagation for range query, and then I'll be leaving the range update for min segment tree and max segment tree. I'll be leaving lazy propagation for as an assignment to you guys so that you can code that. So I'll be taking a problem, we'll be writing down the code for lazy propagation for range sum query in the next lecture. So if you have any doubt or query, of course you can ask either in the comment section or no, don't ask in the comment section. Of course you can ask on the articles that I have created on the code for on discuss.codechef.com. the link I'll be posting in the description. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.